Hello, Carlo. Welcome to the TarGC podcast.
Hello, Luca. Thanks for having me today.
Yeah, it's a pleasure. Carlo, would you like to introduce yourself?
Yes, thank you. I'm a postdoctoral researcher at the Italian Institute of Technology. My name is Carlo Alessi, and I work on deep learning for multimodal robotic manipulation. I can explain a little bit what is the Italian Institute of Technology because maybe it's not so famous or maybe people don't know it. So the Italian
Go
Institute
ahead.
of Technology is a research center in Italy which has several institutes, several centers across Italy. So in particular, I'm at the Center for Robotics and Intelligent System, which is in Genoa. And in this center, I'm part of the humanoid sensing and perception group.
Yeah, nice. So I knew about the IIT, but I guess because I have some kind of academic background. But yeah, thank you for introducing the institution as well. And so yeah, robotics manipulation, and the buzzword now is physical AI. So yeah, give us some context about this amazing and interesting word.
Well, it's a tough question because there is so much going on nowadays with all these recent but very promising companies. I like to think about Figure, which is a company in California where they are building this very cool humanoid, and the company is vertically integrated. They build everything from the hardware to the AI, and their mission is to solve physical AI, as you introduced. So, which essentially means making the robot do intelligent things in the real world, manipulation in manufacturing scenarios, or healthcare, or maybe at home.
So we are going to have a robot companion at home that is going to iron stuff and washing the dishes and stuff.
Well, this is a vision that goes back to the Asimov novels, so I, Robot, which I think is inspiring many researchers since many years. I don't know if it will happen soon, but people will make it.
Yeah. And how does your research fit in this context?
Well, I'm focused for now in manipulation, which is essentially like humans do. They take objects and make stuff with it. For example, they grasp an object and they place it somewhere else. So in particular, I'm applying deep learning techniques to solve these manipulation problems more effectively. And I'm applying this to different embodiments. I started with soft robots while I was doing my PhD. And then I moved on to prosthetic hands, and now I'm working with humanoids. Just to give you an overview.
Yeah, and can you tell us what are the differences between a soft robot, a prosthetic hands, and a humanoid one? I can kind of get, but still.
Well, the difference number one is the morphology. And with morphology, I mean it's a very general term that can mean a difference in geometry, so how the robot is designed, let's say, but also difference in materials. So a soft robot is typically built with materials that are soft, which means the Young modulus is low. So it can it's closer to a rubber than it is to a metal, let's say.
Okay.
Whereas a prosthetic hand, of course, is a hand with a specific purpose, which has to be anthropomorphic to be used and accepted by a human that unfortunately had an amputation, which is rigid so far.
Right.
Most of them are rigid, as far as I know. And then humanoid robots are designed to resemble more or less us, to operate in the environments that are designed for humans.
And what are the challenges of this kind of line of research?
Well, in manipulation, let's say, is the last layer. So let's say is the intelligent layer of robotics. So there are many challenges that first of all come from the hardware. So there are, if someone is focusing only on software, it has to cope with hardware that is built by someone else. So for example, when I was doing manipulation with soft robotic arms, I used a robotic arm that was built by the lab next door. So first of all, I had to understand what they've done and all the limitations of the hardware, which, by the way, people that manufacture most of the time don't use it. So they don't know all the limitations, or they didn't do the test. So, but when you are doing manipulation, you make a stress test, for example, of the hardware. So I discovered, for example, that there were manufacturing variabilities in the actuator, and so I designed some strategies to cope while I was designing a policy for manipulation.
Okay. And how does AI as a role in your research, in your work with manipulation?
Thanks for the question. So, artificial intelligence, or to be more specific, deep learning methods are pervasive in all the pipeline of robotics. So they can aid design, but in my research it was helpful in perception and then in control. So in perception has been useful in two ways. One, when we were building a soft robotic arm with an embedded sensor. Just to give you some context, currently soft robotic arms are at a very at a stage that are prototypes, so they don't have ways to access their state. So the state of the robot typically is the position of the end effector, and so that you can use to control it, basically. So in most of the works, this proprioception is solved by motion capture systems.
Okay.
But but is emerging as a research direction to build soft sensors that can be embedded in the body, and that was what my colleagues were manufacturing, and I was employing deep learning techniques to map these nonlinear sensor readings to the end effector position, basically to have a better proprioception than using motion capture systems.
So if I got it right, so these kind of soft robots, they cannot understand where they are, basically.
Exactly. Yes, they come without by the, let's say, the baseline is that they don't have electronics embedded.
Okay.
So you cannot read anything.
So it's external, basically. So from an external system, you can basically see where they are and tell them.
Yeah, what people do for convenience is to attach markers at the tip, and then they track them with motion capture systems.
Okay.
But the next step is to build the sensors, embedded sensors that do not constrain the movement of these dexterous robots, so that you can have proprioception, and then on top of that you can do manipulation more easily.
Okay, now got it. Yeah, thank you. And there has been actually application of AI also for your other use cases, so the prosthetic hands and the humanoid application.
Yes. So so I did a PhD in biorobotics, where I was working with soft robotic arms. So the limitations was that was the hardware, as I said before. So I couldn't. So what I achieved was a pushing task with a dexterous soft robotic arm with only proprioception, where the proprioception was again taken by a motion capture system. So this was a limiting factor to do more complex stuff. So then when I moved to the Italian Institute of Technology, I could use other kinds of hardware. So in this case, a prosthetic hand, which has these sensors for proprioception, where you can read the position of the joints. So you know the position of the fingers and also of the wrist, because this prosthetic hand called Hannes, which is developed by IIT and INAIL. So has this kind of information, and in particular also had a camera in the palm, which is pretty unique in robotics. And it's cool because you can use it to see the object and do an action according to how the object is oriented. So what we did was to do grasping with behavior cloning. So behavior cloning is a type of imitation learning, where the human first collects demonstrations of a task in teleoperation, and then you can basically apply supervised learning to learn a policy that imitates the data.
Okay, so you're imitating a movement that has been designed, let's say, or done by a human operator. So you take the data and you train the end to operate the same way, with that as an example.
Yes, exactly. So in practice, we collected a data set of almost 500 demonstrations of grasps, and we divided this in 3 scenarios. So grasping from a table, or from the top of a shelf, or during the handover, so a human that passes the object to the prosthetic hand. Across 15 objects to have some generalization, and then once you had this data, we trained a diffusion policy to predict the motion of the hand, so the fingers opening and closing, and the rotation of the wrist.
Okay. And has this been applied in some kind of real world scenario, or is it still kind of so limited to academia as a research?
Well, the hand it's being used by people, but
Okay.
not with a policy yet.
Okay.
So having a policy deployed in the real world for a user, so an amputee, it's challenging in many ways. So it's still research.
Okay. Okay. That's cool. So, and moving to humanoid robots, is it a lot different from the prosthetic use case?
It is different. So thanks for the question. So the thing of learning a policy with a prosthetic hand is that you don't have a robotic arm that moves the hand. The robotic arm is the user. So the user can do motions that are not in the data, and so the policy doesn't work as expected.
Okay.
Whereas with humanoids or with robotic arms plus a robotic hand, it's easier, although it's still, there are many challenges anyway.
Yeah, of course.
But at least the problem of repeating the task is less challenging, because you also train the arm.
Yeah. So it's a more controlled, like in some way, environment, because
it's
you
more
control the arm.
Yes.
Yeah. Okay. Yeah. And so, how your research, what did you achieve applying, AI in this kind of context of humanoid robots?
This is a work in progress.
Okay.
But what I'm doing is to to give you some context. I'm working in the ErgoCab project, which is a collaboration between the Italian Institute of Technology and INAIL. INAIL is the Italian Institute for Insurance for Work Accidents, and so their idea was to make a humanoid that could help workers to do maybe heavy tasks, such as lifting packages, or this kind of stuff, welding, that cause musculoskeletal problems. So to prevent this kind of risks. So what I'm doing is to, in practice, is to make a reinforcement learning policy that can make the robot lift boxes manually. And in particular, we want to leverage tactile perception. So this ErgoCab, the humanoid, has tactile fingertips. So at the fingertip of each finger, there are tactile sensors. And so this includes many challenges, because reinforcement learning, because it's sample inefficient, is typically done in simulation.
Yeah.
And then transferred to the real robot. But since we didn't have a simulation of the real tactile sensor, we first built a simulator of the tactile sensor. And that is another area as well where deep learning is contributing, because these tactile sensors, as you can imagine, they are very noisy, and like the soft robot, they are not repeatable. There are manufacturing errors that you have to account, and makes everything downstream very challenging.
Yeah, of course. So you don't have clean data, let's say, that you can use that are perfect, and there are a lot of noise errors that you need to deal with.
Yeah, but that is the peculiarity of physical AI, right?
Yeah.
I mean, in the real world is everything messy.
Yeah, and unpredictable, I guess.
Yes.
Yeah, cool. And so you mentioned that this is a work in progress. So what are, in your opinion, the next step when it comes to this line of research? So what are the challenges that we're going to tackle next?
Well, some challenges are related to making the robot do different tasks.
Okay.
And that is typically where something that is very well developed in the digital world is coming recently in robotics, which is using language. So
Yeah.
now large language models, but also vision language models are are applied to make robot policies. And the challenge is to make them work well, not just
Okay.
for a demo, not just for a video, but repeatedly for many tasks.
Okay. And so, my last question is, when should I expect to have a robot buddy at home to help me with home
Robot
chores?
buddy, okay.
Yeah.
Well, I don't have the expertise to predict such a huge shot. I am conservative, let's say 20 years.
Oh, okay. Oh my God. Yeah. But yeah, probably will be in time for when I get older. So I can have some help from a robot at home. Yeah. That's fair.
Yes,
That's
yes.
fair.
But
Cool.
I wouldn't expect, I mean, don't take life decisions based on that. I mean,
Yeah. Yeah, yeah. No, yeah, of course. Makes sense. Makes sense. Yeah. I will wait, but without relying on it.
yeah, don't rely on it.
Okay, cool. Well, Carlo, thank you very much. It was a very interesting chat, and for sure now I learn more about this line of research that is, not so common to talk about. So thank you very much again.
Thank you, Luca. And if you have any follow-up question, just text me.
Yeah, cool. Yeah, we can do another episode in the future.
Okay, maybe next year.
Yeah, of course, of course. So thank you very much, and thank you for listening, and see you at the next episode.